All right, we're going to start with Chapter 2, Section 5, Day 1, Rational Functions. So first we're reviewing the parent functions and their key features, for the parent rational function. Looks like f of x equals 1 over x. This blue part I wrote for later. So it's 1 over x. And it looks like this. You know that there's a vertical asymptote at x equals 0 because that's what would make the denominator equal 0 if x equals 0. We know that there is a horizontal asymptote at y equals 0 because it's the parent function. And if we look at the horizontal asymptote rules, it's when the degree of the numerator is less than the degree of the denominator, you have a horizontal asymptote at y equals 0. So if there is not an x at all, that means it's x to the 0 power. And anything raised to the 0 power is just 1. And in the denominator, we have x to the first power. So HA at y equals 0. And then what about discontinuities? So a discontinuity is a break or a hole or a jump in the graph. So if you can trace the graph, the entire thing, without picking up your pencil, then it's continuous. But this one, to get to this other portion of graph, I have to pick up my pen and then come over here to finish it. So I had to go over this vertical asymptote. So it is discontinuous. And the type of discontinuity is an infinite discontinuity at x equals 0. All right, so that's our review of the basics. The definition is a rational function is the quotient of two polynomial functions. So you're dividing. F of x equals a of x divided by b of x, as long as b of x does not equal 0. That's what a rational function is. So then the next part is we have graphs of rational functions. Now I'm going to give you the steps for graphing a rational function. You're going to follow these steps every time. So step 1, find the vertical asymptotes. To do that, you set the denominator equal to 0. Or if you're in factored form, you can set the factors of the denominator equal to 0. Then step 2, find your horizontal asymptote. In order for my rules to apply, I let n equal the degree of the numerator and let d equal the degree of the denominator. And you can compare them. So if n is less than d, the degree of the numerator is less than the degree of the denominator, the way it is in the parent function, then you have a horizontal asymptote at y equals 0. The second scenario, if the degree of the numerator is equal to the degree of the denominator, then you have a horizontal asymptote at y equals the ratio of the lead coefficients. So for example here, if you had f of x equals 2x to the third over 3x to the third, they're this n equals d, 3 equals 3. They're raised to the same power. So we look at the ratio of the coefficients, 2 over 3. So the horizontal asymptote is at y equals 2/3. That is when the degrees are equal to each other. And then the third scenario is when the degree of the numerator is greater than the degree of the denominator. There is not a horizontal asymptote. So like if we had x to the 4th over x to the 1st, degree of the numerator is greater. So there is no horizontal asymptote. However, there's an exception. If the degree of the numerator is exactly 1 more than the degree of the denominator, then a slant or oblique asymptote exists at y equals the quotient of polynomial division. So if you had degree 3 over degree 2, that would be exactly 1 more. So then you would have to do synthetic division, or not synthetic division, polynomial division, to find out the equation of the oblique asymptote. And you can use the word slant or oblique. It doesn't matter which one you call it. It's talking about the same thing. We're not dealing with that today. We will deal with that tomorrow. So this is a side note. Shelf that for tomorrow. It's not in your homework problems I'm giving you tonight. And step 3 is the x-intercepts. To To find x-intercepts, you're going to set the numerator equal to 0, or if you're in factored form, set the factors of the numerator equal to 0. And it will give you x-intercepts. And those are your 3 steps.